Okay, now that we've covered the harness routing and installation for your Megasquirt plug-and-play harness and ECU kit, it's time to go over the initial calibration and Tuner Studio settings. I'd like to preface this video with the following statement. While these products are engineered to be as user-friendly as possible, this process will not be for the novice user. If you are a novice or beginner when it comes to EFI systems, we always suggest hiring a professional to help you through this setup and install. But we also encourage do-it-yourself learning if you have the aptitude. If you would like to gain some more in-depth knowledge into how these systems work and operate, as well as how to do more intermediate level tuning, we highly recommend purchasing these books found in our Amazon store, as they have a ton of information that we can't cover in today's video, and they will help you learn the full scope of what you're able to adjust and the cause and effects of such adjustments. Something else I'd like to address is if you're watching this video for the first time, please sit through and watch the entire thing first before skipping ahead. Unless you were prompted to skip ahead based off of your specific setup, we've really trimmed this video down to contain absolutely essential information, and skipping over portions will result in potential drivability and setup issues. So please make sure you get every bit of information covered in this video. We wouldn't put it in the video if it wasn't important and valuable for you to know. Some of the tools you will need will include a timing light and a remote starter switch or a helper to turn the key. For single coil setups, just a basic inductive timing light will do the job. If you're running a multi-coil spark setup, the only timing light we currently support for our kits is the Innova 5568 Pro Digital Timing Light, as they have a specific mode that we will use that we will cover later in this video. Now before we get started, I realized that I forgot to cover the intake air temp sensor during our initial installation video, so let's cover that real quick. Typically in our setups, the intake air temp sensor is technically not mandatory, but it does help in a few key areas that I will explain more in depth later in this video. But essentially it is helpful for logging your charge temps to make sure you're getting good cooling across your intercooler, or to track if you're heat soaking the engine and need to make adjustments in your setup. The other thing that can be helpful is you can actually retard the ignition timing based off of your charge temps. So if you're running a non-intercooled setup, this will be especially helpful in protecting your engine when you start to heat soak after extended spirited or track driving conditions. The intake air temperature sensor for all naturally aspirated vehicles can be mounted in your intake pipe anywhere within 12 inches of the throttle body inlet. The same applies for all turbocharged vehicles, but it is especially important to make sure on turbocharged setups you're on the cold side piping or post-intercooled piping, as this will be the most accurate reading of the air temperature entering your engine. If you purchased one of our cold air intake kits for naturally aspirated vehicles or one of our intercooler kits for a turbocharged vehicle, you have the option to purchase it with a pre-welded 3/8 NPT bung. If you're piecing together your setup on your own, you can purchase a steel or aluminum weld-on bung from our Amazon store. Our ECU and harness kits come pre-tested on our in-house test engine to ensure you get a 100% quality controlled product right out of the box in an effort to bring you the highest quality possible. We also preload them with a base tune before it leaves, but sometimes the tuning software can cause some weird issues during the initial connection to your laptop, so we want to make sure that nothing inadvertently gets wiped from your ECU. We're going to start by hooking up the DB9 tuning cable to the ECU and then hooking it up to your laptop with the provided serial to USB adapter. If you haven't downloaded Tuner Studio, now would be the time to do so. Visit tunerstudio.com and hover over to Downloads, where you can click the link in the description below. Tuner Studio Lite is the free version that will do about 90% of what you need it to, but we always advise upgrading to one of the paid versions so that you can utilize the auto-tune function and also data logging for any diagnostics. If you choose to pay for the upgraded version, it is a one-time fee and you can upload it to multiple devices. Tuner Studio will work with any Windows 7 and up laptop, as well as any modern Apple laptop. If you did purchase the upgraded version of Tuner Studio, there are times where your screen will look different, so any differences will be highlighted throughout this video. Once you get Tuner Studio on your laptop, go ahead and open it up. When you get to the home screen, you're going to click on File in the top left corner and click on Open Project. In the pop-up box, double-click on MS2 Extra Example and allow it to load. Once you have populated the MS2 Extra project, you'll need to turn the ignition key to the on position. Do not start the vehicle. A lot of times the Megasquirt will immediately connect with Tuner Studio, so if it does, you can skip past this communications setup portion. If Tuner Studio doesn't immediately connect to the ECU, you will need to configure the initial communications settings to get Megasquirt to communicate with your laptop. Click on the Communications drop-down menu and select Settings. Under Connection Type, make sure RS-232 serial interface is selected. The COM port and the baud rate will auto-populate based off of what the USB port is picking up from the Megasquirt. Click on Detect and let Tuner Studio complete its search. You should see the ECU pop up in the search box, and once this happens, you can click the ECU once and then click Accept. You should now have communication between your laptop and ECU. However, if this is not the case, in some rare instances you may need to download an additional driver set, which can be found in the link below. These newer USB adapters are significantly less buggy than the previous generation units, and we find it very rare to need additional drivers. Once you get to this point, you may get a couple of different pop-up messages depending on which version of Tuner Studio you're running. Sometimes it will just automatically connect and you have 0 error messages. Sometimes you will get a firmware signature mismatch warning. This means the firmware that Tuner Studio populated is different than what is on the ECU, which is no big deal. All you have to do is select Update ECU Definition, and Tuner Studio will automatically pull the correct firmware. You do need to be connected to the internet for this step, but once the correct firmware signature has been downloaded on your laptop, you won't need an internet connection. Another pop-up warning that could show up on the paid version of Tuner Studio will be the difference report. This is when the tune file in Tuner Studio and the one on your ECU is different. When first connecting to an ECU, you always want to hit the Use Controller Settings button. If you pick Send Current Tuner Studio Settings, it will wipe the existing tune on the ECU and flash whatever bass tune is preloaded in Tuner Studio. Don't panic if you accidentally click the wrong button. Just email us and we'll send you another copy of the bass tune we preloaded onto the ECU. If you end up clicking all of the right buttons, you are now live viewing the bass tune file that is on the ECU, so this would be a good time to save a copy of this. In fact, it's always a good practice to save multiple copies just in case you accidentally corrupt a copy or make too many edits and need to backtrack. First, we want to save the bass tune file as it sits, so this can be your earliest point of reference. I like to label what the tune file is and then the date, so in this example, we're going to call it bass tune and then today's date. Click Save, and then we're going to immediately create another file that we edit. You'll notice the bass tune we just saved is here, so we'll call this next one Setup and First Start Attempt and then today's date. Now once you start making changes, if you've gone too far, you have a completely untouched bass tune file to refer back to if you screw anything up. This is a great habit to build throughout your tuning process. Make as many backups as you can. The more you have, the easier it is to backtrack and figure out what happened if you set something up incorrectly. Now we need to go through and verify that all of your settings are set up correctly. The first thing we need to check is make sure your required fuel calculation is set correctly. We're going to use our test engine example, but this will vary based on your specific order or your specific setup, so these values are not going to be 100% reflective of what your setup is. Click on Basic Load Settings, and then click on Engine and Sequential Settings. From here, click on Required Fuel, and make sure all of these values are correct. We typically like using metric units of measure, so we use cubic centimeters for displacement and cubic centimeters per minute for flow rate. Make sure your engine displacement matches your setup, so for L28, which is a 2.8 liter, that translates to 2800 cc's. Number of cylinders is 6, and your injector flow rate is going to match what you have. If you are putting this on an otherwise OEM setup, all non-turbo injectors are 195cc, and all OEM turbo injectors are 265cc. Air-fuel ratio stays at 14.7, which is a stoichiometric ratio for gasoline. Click OK after verifying all settings are correct for your application. If you've made any changes to any of these values, make sure you click Burn and then close the box. Burn will make sure that your changes are flashed to the ECU. Next, we're going to click on Basic Load Settings and then click on General Settings. Typically, the only two variants we will cover are going to be the standard map sensor in the Megasquirt or the MAPDaddy 4-bar upgraded sensor, and unless you have the MAPDaddy sensor upgrade, you will not need to change anything or check anything in this menu. If you do have the MAPDaddy sensor, make sure your screen matches this screen of all of the different settings that need to be changed. If not, just continue moving forward. Next is going to be our Rev Limiter Settings. Click on Basic, Load Settings, and click on Rev Limiter. The OEM L Series has a hard rev limit at 6,500 RPMs. However, depending on your camshaft setup, this can be increased. If you are running a factory L Series cam, your power band typically drops off at about 6,000 RPMs anyway, so you shouldn't need to change this. However, for some of the Schneider, Isky, and other cams out there, they still make power well into the high 7,000s, so you can adjust this setting accordingly. Set Spark Retard Mode to fixed angle, and set your Retard 2 setting at 0 degrees. Next, enable Spark Cut and make sure Fuel Cut is turned off. After this, we're going to move on to the fuel settings and check our injector dead time. Click on Fuel Settings and click on Injector Dead Time /PWM. This value determines how long your injectors stay closed in between cycles, and the wrong setting here can cause your injectors to overheat and fail, and also drivability issues. While each injector manufacturer has their own specific dead time values, a good general rule of thumb to follow is going to be 0.7 milliseconds for low impedance and 0.9 milliseconds for high impedance. All OEM fuel injectors are Bosch EV1 style, and they are low impedance. Additional low impedance injectors that are commonly used are the Supra 7AM GTE injectors, as well as the Mitsubishi DSM 450cc injectors. All of the Bosch EV6 injectors we sell are high impedance. If you're not sure what your injectors are, use a digital volt ohm meter and check the resistance across your injector terminals. If you read in between 1 to 4 ohms, you have low impedance injectors. If it's between 12 to 16 ohms, you have high impedance injectors. For low impedance injectors, you will want to make sure that your injector dead time is set to 0.7 milliseconds. PWM current limiting is switched to on. PWM current limit percentage is set to 30. PWM time threshold is set to 1 millisecond, and injector PWM period is set to 66 microseconds. For high impedance, you will make sure your injector dead time is set to 0.9 milliseconds. Make sure PWM current limiting is switched to off, and that's it. Next, we're going to calibrate all of our sensors, starting with the throttle position sensor. This is one of those things where getting it wrong will cause a no-start condition. The throttle position sensor reading can cause the injectors to not pulse because the ECU is programmed to cut injector pulse at anything above 70% throttle while cranking, which is called flood clear mode. So if your TPS is unplugged or out of adjustment, you could be within that threshold and you won't have any injector pulse. Click on Tools and click on Calibrate TPS. With the throttle fully closed, click on Get Current next to the closed throttle ADC count. Next, press the gas pedal all the way to the floor and click Get Current next to the full throttle ADC count. Once you've completed this sweep, click Accept. Next, we'll calibrate the coolant temp sensor. Click on Tools and click on Calibrate Thermistor Tables. If this is grayed out, you will need to click Unlock Calibrations. For sensor table, make sure coolant temperature sensor is selected, and then under common sensor values, make sure GM is selected. Lastly, make sure your temperature value is set to Fahrenheit, click Write to Controller, and then click Close. Almost all of our modern Megasquirt kits feature the GM style coolant temperature sensor, but if you have an older kit of ours and you're running the factory Nissan cylinder head temperature sensor, the calibration will go as follows. For sensor table, make sure coolant temperature sensor is selected, and then under common sensor values, set that to the very top option labeled Select a Common Sensor. The value will be grayed out after selecting, which is normal. Your bias resistor value will be set to 2490, and make sure your unit of measure is set to Fahrenheit. We're going to set 3 temperature points and 3 resistance values. The first temperature point will be negative 40 degrees Fahrenheit. Resistance value is 32,000. The next temperature point is 80 degrees Fahrenheit. Resistance value is 2250. The final temperature point is 160 degrees Fahrenheit, and the resistance value is 360. Click on Write to Controller, and you're done. Next, we're going to calibrate the wideband. Click on Calibrate AFR Table and get your wideband communicating with your ECU. The AEM 3000 series we supply with our kits uses a preloaded table found under the Ego Sensor drop-down menu. Select AEM Linear 30-42XX option and then click Write to Controller. If for some reason later on you notice that the wideband is reading differently than the Megasquirt ECU reading, you may have to manually populate the voltage tables found in the AEM install instructions. Some of our older kits came with the GlowShift Digital 10 Series Wideband, which we have stopped selling, but for those of you who still use that, you would select the Innovate/PLX as your ego sensor. Depending on what wideband you do have, there may be a preloaded table in Tuner Studio, but if not, just like in some cases with the AEM gauge, depending on your wideband of choice, you may have to manually enter the voltage table found in your wideband instruction set. Next, we're moving on to some of the cranking settings. Under Startup/Idle, click on Cranking and Startup Settings. Verify cranking RPM is set to 500. Verify flood clear TPS percentage is set to 70%. This value sets the throttle position to kill injector pulse to clear a flooded engine while cranking. If the ECU sees over 70% throttle during cranking, it will kill injector pulse, which means if your TPS is left unplugged or out of adjustment, the vehicle will not start, as its default setting, unplugged, is 100%. Make sure you have this plugged in before your first start, otherwise you will experience a no start condition. We're getting really close to attempting to start the vehicle for the first time. One last step is going to be verifying your overboost protection is enabled. If you're running a turbocharged setup, please pay attention to this. If you're running a naturally aspirated setup, you can skip ahead. This will add an additional layer of protection during your initial setup and tuning, as the last thing you want to do is get into a higher boost pressure range and pop something due to not being fully tuned. Click on Boost/Advanced and click on Boost Control Settings. We'll go over some of the add-on functions later in this video. For now, we're going to specifically cover the overboost protection. On the right-hand side, make sure overboost protection is set to spark cut. Maximum boost measured in kPa is going to be the maximum boost allowed before the ECU stops sending a spark signal to your coil. Our default setting is 180 kPa, which equates roughly to just north of 12 psi of boost, depending on your elevation. We would suggest leaving this alone for now. Just make a mental note of it later when you start tuning. Depending on your desired boost pressure, you'll want to raise this later. Now we can move on to your ignition settings and attempt the first start. Before you begin this step, it is always helpful to have a battery charger on your battery, as well as possibly a second set of hands to crank the engine for you. However, if you're by yourself, we always recommend purchasing a remote starter switch from our Amazon store to make this a one-person job. Unplug your fuel injectors, as you will be doing a lot of cranking and settings changes to get this dialed in initially, and you will foul your spark plugs in the process if you do not unplug the injectors. If you do end up fouling your spark plugs, it will cause a whole host of issues, including not getting any spark output from your timing light, which can lead to a lot of confusion, cussing, and or hair pulling. So yes, please unplug all of your fuel injectors. For multi-coil spark setups with our 24-1 drop-in crank angle sensor, verify these settings below. Click on Ignition Settings and then click on Ignition Options/Wheel Decoder. Verify Spark Mode is set to toothed wheel. Verify Skip Pulses is set to 2. Verify Ignition Input Capture is set to falling edge. Verify Spark Output is set to going low. Verify Number of Coils is set to wasted spark. Verify Spark A output pin is set to D14. Verify cam input is set to cam input. Verify trigger wheel arrangement is set to dual wheel. Verify trigger wheel teeth is set to 24. Verify tooth number 1 angle is set around 265 degrees. This setting is based off of our test engine and orienting the crank angle sensor in this manner per our installation video. This setting will vary per vehicle, so treat this as a general ballpark number that will be accurate within plus or minus 20 to 30 degrees, as long as your distributor is installed properly. This gets adjusted a little bit later on. Verify wheel speed is set to cam wheel. Verify second trigger active on is set to falling edge. Verify and every rotation of is set to cam. Now on the right hand side of the ignition options menu, verify cranking dwell is set to 6.0. Verify cranking advance is set to 12.0. Verify dwell type is set to standard dwell. Verify nominal dwell is set to 3.0. Verify spark duration is set to 0.7. If none of these settings needed to be changed, simply click close. If you had to make any changes at all, click on burn and then click close. This is a good habit to form anytime this button is colored, as it indicates changes made. Another good habit to form is pressing Ctrl S on your keyboard, which will automatically save your progress. If you form these two habits as you go through and make minor changes to your tune, it will be very easy to backtrack when you've made a mistake. Earlier in this video, we mentioned the use of the Innova timing light sold in our Amazon store, and we're going to talk about how to get this set up for the correct mode now. You notice on this timing light there are 4 pigtails. There's a red one and a black one. This is your power and ground. You can just connect this straight to your battery. This is your induction pickup. It does have an arrow that faces towards the spark plug. It will work both ways, but it may give you erroneous readings or delayed readings, whatever. Just follow the instructions, point that towards the spark plug, and you won't have any problems. This green lead is not used. If you want to know further about what it does, read the instruction manual that comes with it, but for this video, it is irrelevant. On power and ground, it lights up. Now we're going to hook up to number 1 spark plug, and we're going to point the arrow towards the spark plug. Now, one little tidbit that a lot of people don't realize, because this is an induction pickup, which means it picks up the movement of electricity, you can put it across the spark plug wire, but if for some reason that's not accessible or you just don't want to do it, you can hook it up around your ignition coil lead. It will pick up the inductance of the 5-volt square wave signal going to this ignition coil. So that is also an acceptable way of reading number 1. Just make sure it's on number 1. Next, we're going to review the initial setup. So this is a crucial factor in making sure that your readings are correct. So you can see we're in the initial, just basic first boot up screen, right? You need to hit the down arrow and the F button at the same time. You hit it until it goes to this screen. This is your ignition advanced screen. You hit it again. Sometimes it takes a little bit of practice, but you'll notice here now 2 with a circle is highlighted and the 4 with the circle's gone. I can click back and forth until it goes to 4. That means 4 cycle mode. We need to be in 2 cycle mode. So you just set your adjustment. See, I timed it there perfectly to where it just adjusts back and forth, right? If you don't hit them at the exact same time, it doesn't always work. So you just keep doing what you're doing until you get it where it needs to be. So you're in 2 cycle mode. The second thing that needs to happen is you need to preset your advance. And the reason we do it this way, it's just easier for our internal purposes. You don't have to do it this way. We preset the timing light to 12 degrees, which is what you should be firing when you're cranking. So the computer is pre-programmed to 12 degrees. If you have 12 degrees programmed into your timing light, all you have to do is line up your 0 marks. You don't have to get confused and try to find where your 12 is. Because the factory timing plate just doesn't have as much resolution, or you may not have as much access to it, right? And a lot of modern cars only have the top dead center mark. So if you set your ignition advance to match what's commanded in the ECU, all you have to do is line up your top dead center mark. And so now that we have this pre-calibrated, we're going to go into Tuner Studio, and I'm going to show you what setting you need to adjust. We're going to be making our timing adjustments out of the tooth number 1 angle setting towards the bottom left-hand side of the ignition options menu. You can make finer adjustments in increments of 1/10 of a degree or larger adjustments of 10 to 20 degrees at a time. With a helper or remote starter switch cranking the engine over, get a baseline for your timing mark. If your timing light is flashing, but you're not seeing your TDC mark anywhere, make adjustments at 20 degrees at a time until you see your TDC mark on your crankshaft balancer. If you stabbed your crank angle sensor in per our previous video instructions, this base setting we have should be really close, and you shouldn't have to venture too far off. Get it close enough for your marks to line up while cranking, and once that happens you can stop and plug all of your injectors in, and you can attempt to start it and see if it will run under its own power. Once you've got it running, you can make minor adjustments at your number 1 tooth angle in 5 to 10 degree increments max, hitting burn as you make each adjustment and seeing where it tracks on your timing light. We like to make these finer adjustments at operating temperature, so let the engine fully warm up and then go into ignition settings and click on ignition options. On the right hand side under fixed advance, it should be set to use table by default. We're going to change that to fixed timing. 2 boxes down you'll see timing for fixed advance. We have it set to 12. This allows you to dial in your ignition timing exactly to 12 degrees and will hold the ignition timing commanded by the ECU to 12. This way you don't have the ECU trying to go into its advanced curve while you're trying to set your idle and base timing. This can be especially helpful if you have a high idle condition. While it is in fixed advance mode, you can make your timing adjustments under the number 1 tooth angle box. Once you've dialed in your fine-tuning adjustment, make sure you change the fixed advance setting back to use table so that the ECU utilizes your full ignition timing map. The next steps from here are getting your fuel ratios dialed in. I'm not going to cover in-depth tuning techniques in this video, as this is a general setup and first start video, but I will provide some basic pointers that will steer you in the right direction. For more in-depth tuning practices, we're going to release a separate video covering a lot more technical information there. But for now, your main thing is you want to get your air-fuel ratios dialed in at operating temperature first. We highly recommend paying for the upgraded license so that you can utilize the auto-tune feature, especially if you're a beginner or intermediate user, as this will take about 90% of the legwork out of this process for you. If you do want to do manual corrections, that can be done at the VE table under Fuel Settings. Open it up, and with the engine idling at operating temperature, if you highlight this general area, this is going to be your idle cells. Most L engines are going to hover around here, but if you have an aftermarket cam or other setup, you may not see this much vacuum at idle. You can highlight this general area and then use the addition or subtraction tool to add or remove fuel from this entire area to get your AFRs closer to 14.7 to 15.3 to 1. We like to see around 15.3 to 1 at idle, which is slightly leaner than stoic. Just get it in the ballpark and you can make finer adjustments as you go. If you're going to utilize AutoTune for this feature, this is where AutoTune really shines, as you can let the software do the work for you. You'll notice under Fuel Settings there is another table labeled AFR Table. This is what the AutoTune software uses as a base map to correct your VE table. Basically, the AFR table is what you are commanding the ECU to do. The wideband feeds data back to the ECU, and if the wideband reading does not match what the AFR table says, the software will correct the fuel mixture until it matches. As it corrects the fuel mixture, you'll see the numbers turn red or blue. Red means it's trimming fuel away, and blue means it's adding it. It will only adjust each cell a certain amount before it stops, but clicking reset will allow it to begin correcting again. So if you're really trying to get those numbers to pull in, it is a normal practice to repeatedly hit reset until your AFRs are where they need to be. Once you have done this, if you're having trouble keeping the engine idling, there are a couple of things you can employ to get a better idle quality. The first part is timing advance. Anytime you advance timing, you will pick up engine speed. And using this method, we found we have never needed an idler control valve for any Datsun we've ever tuned, even with AC equipped vehicles. You're going to be finding a balance between the minimum air rate screw at the throttle plate and timing advance. Set your minimum air rate screw where your engine is idling at around 800 RPMs. Under Ignition Settings, open up the Ignition Table 1 table. You'll notice the X-axis has RPM plotted across it, and the lowest RPM is 500. That entire cell can have the timing advanced to help kick the idle speed up in the event that it drops below your desired RPMs. Lastly, once you've got your fuel mixture dialed in at operating temperature, you're going to want to adjust your cold fuel mixture as needed. Depending on the time of year, you may not be able to get a full adjustment in, so you may have to revisit this in the winter or summer to get it dialed in properly. Under the Startup/Idle menu, select the Warm-Up Enrichment table. You'll notice a percentage correction next to plotted temperature points. This setting is a multiplier and it adds fuel above your existing operating temperature map. You can change any of the values in there, but leave the very last value at 100%, 20 degrees below your full operating temperature, which is when your warm-up enrichment correction will taper off. Typically, cold idle AFRs should float around 13 to 1 to 13.5 to 1 for pump gas, so you want your warm-up enrichment values to correct your fueling to where you see that air-fuel ratio. The final piece of the cold start/warm-up enrichment tuning is going to be giving a little bit of extra timing advance during cold starts. If you find your vehicle has a hard time idling when the engine is cold, you can add some additional timing advance when it's cold. Click on the Ignition Settings menu and click on Cold Advance. This table will allow you to add up to an additional 10 degrees of timing advance based off of what temperature the engine is at. I found in very cold situations, you're basically maxing that setting out at 10 degrees to give the engine as much help as it can get. Other instances, you're not really giving it any advance at all. There are several factors across all of these warm-up settings, such as elevation, humidity, ambient temperature, fuel quality, and so on and so forth. So you'll need to play with it within your specific environment until you get it all dialed in. If you're running our 24-1 crank angle sensor kit and you run into a sync loss issue at higher RPMs, typically what happens is you will notice a hard rev limit around the 5,000 RPMs and the tach signal will drop to 0 momentarily until you let off the throttle. What's happening is the crank position and number one cylinder signals happen too close together sometimes and can cause interference. So what we do is go into ignition settings and change how the ECU reads the sensor. Under ignition input capture, if it is set to rising edge, change it to falling edge. Under second trigger active on, if it's set to falling edge, change it to rising edge. Making this change will require you to reshoot your base ignition timing shown earlier in this video and retest. The majority of the time, swapping these two settings around will alleviate the condition. We have had some instances where we had to set both pickup points to rising edge or both pickup points to falling edge, so you may have to play with it a little bit if the first method doesn't solve the problem. That about wraps up the initial setup and startup of your Megasquirt plug-and-play kit. A more in-depth video covering the complete tuning process is in the works and will be released at some point, but we have a fairly decent backlog of instructional videos to get through currently before that video makes it in production, so please bear with us in the meantime. If you have any technical questions about anything not covered in this video, please reach out to us through our email tech support, godzillaraceworks@gmail.com, and put tech support request in the subject line. If you need help locating a tuner in your area, would like to purchase a canned tune from us, or would like us to tune your vehicle in-house, please reach out to us and we'll do our best to get you taken care of. Once again, thank you for purchasing one of our plug-and-play Megasquirt kits, and thank you for watching.